If negative 8 comma 3 is a point on the terminal side of an angle, what is the reference angle in radians, and what is the smallest possible positive angle containing the point? Let's begin by plotting the point negative 8 comma 3, which is in quadrant 2. And now sketch the smallest possible positive angle containing this point. We know the initial side is along the positive x-axis. The terminal side passes through the given point. If we want the least possible positive angle, it would be this angle rotating counterclockwise. We know on the coordinate plane that tangent theta is equal to y divided by x. So if we call the angle that we want angle A, we know tangent A is equal to y divided by x, which is 3 divided by negative 8, or negative 3/8. And now to solve the equation for angle A, we would take the inverse tangent of both sides of the equation. Simplifying on the left, inverse tangent of tangent A is equal to A. We have A is equal to inverse tangent of negative 3/8. Now we'll go to the calculator, evaluate inverse tangent of negative 3/8, which will help us determine the reference angle as well as the smallest possible positive angle passing through the given point. It's important to make sure the calculator is in radian mode and then enter inverse tangent negative 3/8. To 4 decimal places, we have negative 0.3588. Well, we should recognize right away this is not the angle we are looking for, so let's go ahead and label this A prime. But this angle does have the same tangent function value of negative 3/8. Let's go ahead and sketch this on the coordinate plane. Starting at the positive x-axis, because the angle is negative, we rotate clockwise 0.3588 radians. And the terminal side is going to be in the opposite direction of the angle we are looking for. So this would be the terminal side. So the angle rotating clockwise is negative 0.3588 radians, which means the reference angle would have to be positive 0.3588 radians. And the reference angle of this angle is the same reference angle of the angle we are looking for in the second quadrant. So this angle here is also 0.3588 radians. Now you might be asking, how can this angle in the fourth quadrant have the same tangent function value of the angle in the second quadrant? Remember, in the second quadrant, x is negative and y is positive, and in the fourth quadrant, x is positive and y is negative. So the angle that terminates in the fourth quadrant must pass through the point, this point here, where the x-coordinate would be positive 8 and the y-coordinate would be negative 3. Notice how y divided by x is still equal to negative 3/8. So let's begin by recording the reference angle to the angle we are looking for, which we now know is 0.3588. And now that we know the reference angle, we can determine the smallest possible positive angle passing through the given point of negative 8 comma 3, which would be pi minus the reference angle. So our angle A is equal to pi minus 0.3588. Looking at the notes below, if angle A is between 0 and 2 pi radians and terminates in the second quadrant, A is equal to pi minus the reference angle, which is what we have here. And now let's go back to the calculator. We have approximately 2.7828 radians. I hope you found this helpful.